This refers to how many processes or threads, joblib, parallel will use to run tasks concurrently. The parameter n_jobs controls this. For example, n_jobs equals -1 means it uses all available CPU cores, while a positive integer would specify a precise number of parallel jobs. This refers to how many processes or threads, joblib, parallel will use to run tasks concurrently. The parameter n_jobs controls this. For example, n_jobs equals -1 means it uses all available CPU cores, while a positive integer would specify a precise number of parallel jobs. This indicates the underlying method, joblib, parallel uses to achieve parallel execution. The low-key backend is particularly useful for cases involving extensive data that needs to be serialized, pickled, for communication between processes, as it can better handle this overhead compared to some other options. This aspect is crucial for efficiency when working with large datasets. This indicates the underlying method, joblib, parallel uses to achieve parallel execution. The low-key backend is particularly useful for cases involving extensive data that needs to be serialized, pickled, for communication between processes, as it can better handle this overhead compared to some other options. This aspect is crucial for efficiency when working with large datasets. This parameter determines whether to prioritize using threads or processes for parallelism. Using threads is often simpler, but for CPU-bound tasks in Python's CPython implementation, due to the Global Interpreter Lock, or GIL. Processes generally offer superior performance. Processes have independent memory spaces, thus sidestepping the GIL's limitations. This parameter determines whether to prioritize using threads or processes for parallelism. Using threads is often simpler, but for CPU-bound tasks in Python's CPython implementation, due to the Global Interpreter Lock, or GIL. Processes generally offer superior performance. Processes have independent memory spaces, thus sidestepping the GIL's limitations. Sklearn provides the !parallel class, a powerful tool for speeding up your code. It enables you to run multiple parts of a computation simultaneously, making use of multiple cores in your computer's processor. This is particularly useful for large or complex tasks where you can divide the workload into smaller, independent pieces. Think of it like having multiple chefs working on different parts of a meal at the same time, each contributing to the overall result much faster. The key to effectively using !parallel is to have several tasks that don't depend on each other. Each piece of work can be done independently and without waiting for others to finish. This is like having many separate assembly line stations producing different car parts. Each station completes its task without needing input from other stations. This question is testing your knowledge of the options and settings within Sklearn's !parallel class, which uses !joblib, parallel under the hood to handle the parallel execution. The n_jobs parameter controls how many cores are used. Setting it to -1 means use all available cores, which is usually the fastest way to process things. Think of it like assigning all your chefs to work at the same time to make the meal quickly. This option lets you choose between threads and processes. Processes are generally better for heavy computation, as threads have limitations in Python due to the Global Interpreter Lock, GIL. Processes are separate independent workers with their own memory, unlike threads which share the same memory. Think of it like having separate kitchens, processes, versus having multiple chefs in the same kitchen, threads. The backend option selects the method used for parallel execution. Loki is an excellent choice when dealing with large data because it's designed to handle the serialization, pickling, needed when moving large datasets between processors or cores efficiently. Increasing the number of workers doesn't always proportionally speed things up. There's overhead involved in managing all those workers. Sometimes that overhead cancels out the gains from additional workers. Think of it like having so many chefs in the kitchen that they get in each other's way. This is the core idea: breaking your computation into parts and running them at the same time to speed up the entire process. This section introduces the core idea of using Sklearn's parallel class to speed up tasks by running multiple functions concurrently. It sets the stage for the quiz question by explaining that the joblibparallel class, used inside sklearn is the key player. We'll be focusing on how different settings impact this parallel processing. This section presents the quiz question. The question tests your understanding of parameters within the joblibparallel class. The question focuses on how choosing different settings will affect performance. It's important to carefully consider each answer option. The question begins by establishing the context. You are working with Sklearn class to accelerate a computationally demanding task by independently calling multiple functions. It sets the stage for the multiple-choice questions that follow. Option A explores the meaning and impact of setting njobs to -1. njobs controls the number of parallel processes or threads used. -1 instructs the system to use all available CPU cores to maximize speed. Option B contrasts the use of threads versus processes. Threads share the same memory space, while processes each have their own. The question explores if using threads is faster than processes for CPU-bound tasks, tasks limited by CPU speed. This requires an understanding of the global interpreter lock, GIL, and its implications for Python's performance. Option C focuses on the choice of backend for parallel processing, specifically Loki. It explores whether Loki is well suited for situations with large datasets that must be serialized using pickling before they can be processed in parallel. Option D assesses the relationship between increasing the number of jobs, njobs, and the resulting decrease in runtime. It probes whether this relationship is always directly proportional or if there are other factors involved. This section introduces the quiz format. The question will test your understanding of the Sklearn, utils, parallel class in scikit-learn, a powerful tool for speeding up your code by running tasks in parallel. It focuses on how different parameter settings affect the performance of these parallel computations. Get ready to put your knowledge to the test. This is the core quiz question. It presents 4 statements about joblib. Parallel a crucial component of Sklearn. Utils. Parallel which is used for parallel processing in Python. You need to determine which statements are true and which are false based on your understanding of parallel computing concepts and the joblib library. Consider each option carefully. This statement explores the n_jobs parameter. Setting n_jobs to -1 instructs the parallel processing system to use all available CPU cores on your machine. Is this always the most efficient strategy? Think about what might limit the speed up even with all cores used. Here, we are comparing 2 approaches to parallelism. Using threads, prefer equals, threads, versus using processes, prefer equals, processes, For CPU-bound tasks, tasks mainly limited by CPU speed, consider the impact of the global interpreter lock, GIL, in Python. Does using threads overcome this limitation? What are the implications for performance? The statement discusses different backends for parallel processing, specifically focusing on Loki. Pickling refers to the process of serializing Python objects, converting them into a byte stream for easier data transfer between processes. Consider whether Loki is efficient in handling large data and the overhead involved in pickling. This statement challenges the assumption of linear speedup with increasing numbers of parallel jobs. Increasing n_jobs does not guarantee a proportional reduction in runtime. Think about potential overheads, process creation, communication, etc., and limitations of the task itself. Is perfect scaling possible? What factors might limit this? Hey Vamsi, this line introduces the topic of parallel processing, a technique used to speed up computations by dividing a task among multiple processors. Scikit-learn, a popular machine learning library in Python, utilizes this technique for efficiency. We'll explore how it's implemented here. Okay, Vamsi, the core of our discussion. This line presents a multiple-choice question that tests your knowledge of *joblib. Parallel *, a crucial component within scikit-learn that enables parallel task execution. This means breaking down your tasks so multiple processors or threads can handle portions simultaneously. This statement explores the meaning of the parameter *n_jobs equals -1 . It suggests using all available CPU cores for parallel processing. Think of it like assigning all your workers to a project for maximum speed. Here we're comparing two approaches to parallel processing, using threads versus processes. Threads share the same memory space, while processes have their own. The choice influences speed, especially for tasks heavily reliant on the CPU. This line simply acts as a heading, topic for the main concept involved here. Parallel execution refers to the simultaneous running of multiple parts of a task or program on multiple processors. This is the heart of what we are trying to understand. This line points to a core resource involved in parallel processing, the number of central processing units or CPU cores available to your computer. Each core can execute instructions simultaneously, and it is the main determinant of the maximum speedup achieved from parallel processing. This section introduces the core concept, scikit-learn's parallel class. It's a tool for making your code run faster by splitting up the work and doing it on multiple parts of your computer at once. This is especially helpful when you have lots of independent calculations to perform. We'll explore how this works throughout the rest of the quiz. What do you think are the advantages of using a parallel class? This is the main problem. It presents a multiple-choice question to test understanding of the parallel class and its settings in the scikit-learn library. What key concepts do you think will be important in order to answer this question? This focuses the question on the specifics of the joblib parallel class, which is a vital component of scikit-learn's parallelization capabilities. It's used internally by Sklearn utils parallel to manage parallel task execution. Why do you think the question specifies that joblib parallel is used within Sklearn utils parallel? This option discusses the setting. The njobs parameter controls the number of parallel jobs to run. Means use all available processing units, thus maximizing parallel execution. This option compares and it asks whether threads are faster than processes for CPU-bound tasks, those mainly limited by processing power. The answer will depend on the specific situation and the nature of the task. Here, the focus is on different backends. Is one way to handle the parallelization. Pickling is a process of serializing data, which is essential when passing data between different processes. This option discusses the suitability of LOKY when dealing with large datasets requiring pickling. This statement explores whether increasing njobs always leads to a direct and proportional speed increase. This is not always true in practice because there are overheads involved in managing parallel processes and communications. This part is just to visually separate the problem statement from the answers. This section provides the different options for answers. This is where the final answers would be written.